Well, greetings, eighth graders. We are going to be reviewing here now Big Idea A as well as Big Idea B. We're putting them both together here for the purposes of Don't Eat Yellow Snow because they're such short little sections and the big ideas are so awesome. We thought, well, why not go ahead and combine them together? So I'm just going to click you through the PowerPoint that we were using to kind of guide you through the discussion that happened in class. If you were here, then you'll recall, or if you were gone, then this is what you missed. But basically, we spent a day or so just trying to, or not even a day, maybe 10 or 15 minutes, just trying to review what were some statistics here when it came to water and the earth. All right, so question A1 is our first one. And the question here was how much water is on our planet and how much of it is usable by 7 billion human beings? And as it turns out, the statistics are pretty startling. Turns out that 97% of all of the water on the earth is salt water, and so therefore unusable by us. So that was a bit of a shock. Then, of course, you have the other 3%, which is fresh water. But there's a little bit of a catch. That 3%, two-thirds of it is tied up in ice, icebergs, glaciers, and things of that sort. So really, that 3% is more like 1%. So we, human beings, have access to approximately 1% of all of the Earth's water. When you consider 7 billion people surviving on 1% of the Earth's natural resources, it might give you pause for thought. And if you're looking for an even better chart, because I know that this is kind of a simplistic chart, I would encourage you to look on page 361 of your science textbook because it even breaks down the freshwater into percentages. So out of this little small 3% wedge, how much of it is ice, how much of it is groundwater, and things of that nature. Which really does lead to question A2. And the question is very simple and straightforward. Where are the most common places that you can find water that's usable by the 7 billion human beings? So of that 1%, where do we actually get that water? And I suppose if we include the whole 3% pie wedge here and we include ice and glaciers, that of course is where the largest source of fresh water is, not really accessible by us. So that's approximately 2% of that 3%. The other 1% though would be, in order, groundwater, lakes and rivers, anything that's on the dry land, either flowing or standing still, and of course water in the atmosphere, precipitation, and all of those together account for that 3%. And these bottom three here account for the 1%. And so, since groundwater is really the leading one that human beings depend on, that's one where we're going to focus a lot of our attention in the third Big Idea C. All right, so that's Big Idea A right there, A1 and A2. And the question, the two questions really kind of point us to this realization of that first big idea. And the first big idea is that so much depends on so little. We have so many people, 7 billion human beings surviving on that 1%, and we don't exactly treat that 1% very well. We certainly don't act as if it's 1%. So that's the first big idea. And so moving on to question B1 here. B1 asks about the water cycle, basically. It's asking what happens to water when it lands on the ground. So let me talk you through it here. We have this little clip art right here showing, of course you guessed it, precipitation. Precipitation is the falling of water onto the Earth's surface, either as a liquid or, and I'm sorry that's cut off there, a solid. So remember, precipitation could be hail, it could be sleet or snow, as well as rain. Okay, when it's on the ground, you have a couple options. It could soak into the ground, but what I really want to focus on is this part of the water cycle, which of course is evaporation. Water changing from a liquid to a gas stage. And then of course, once it's in the air as a gas, it can easily reform back into water droplets, which we call clouds, and that process is known as condensation. And you'll see it zip by right here, changing from a gas to a liquid. So what does it look like when we put all three of those things together? It turns out that this is what we end up with, the water cycle. So if we watch this here, and of course this is a little overly complicated more than I just described, but we have water that's on the surface. It evaporates into the atmosphere as a gas. It would later cool down and condense into forming into clouds. Those clouds can precipitate rain, and that water can seep into the ground as groundwater or run off on the surface and fill in lakes and streams and continue that process. And of course, then that really leads us to question B2. Where was all of the water that's in your body? Where was that before your body was here? And the implications of the water cycle are kind of big. What it really means is that water is constantly recycled on the earth. You and I are part of that equation too. We can't remove ourselves from the water cycle. So the water molecules that you're going to drink tomorrow, well, those molecules were here somewhere on the earth being used somewhere else. Now, they might have been in the atmosphere, they might have been in the ocean, they might have been on the ground or in the ground, and they might have been in something else that was alive. In fact, the chances seem pretty overwhelming that that is the case. So, where was your water 1,000 years ago? Where was your water 100 million years ago? And the answer, my friends, is somewhere else. And so that really leads us to the final big idea. And that last big idea is that you and I are made from recycled water. And if that grosses you out a little bit, flip it around the other way and say it in a nicer way, that we are all touched by something ancient. And that's really, truly that second big idea, that we are made from recycled water. We are touched by something ancient. And so hopefully that gives you a nice, warm, fuzzy feeling. And if not, I'm sorry for disturbing you with the water cycle. So that concludes big idea A and B. They're really quick, simple, but powerful ideas. And so now we move into big idea C. A few more puzzle pieces on that one to consider. And so I will see you back for the next video cast once we have a chance to tackle those. Until then, bye.